Alright, so now that we've looked at the graphs a little bit, we're going to talk about what's called the limit existence theorem. So what this says is a limit exists, so we're going to write the limit as x approaches a, this is just any number, of f of x, because remember that just represents the graph or the equation that you're looking at, exists if and only if the limit as x approaches a from the left, with a little minus sign there, is equal to the limit as x approaches a from the right. And this would have to be equal to some constant b. And this limit existence theorem just states that where b is a real number. So it can't be positive infinity or negative infinity, it has to be a real number. So in order for the limit to exist at a value, at x value, the left side of the limit and the right side of the limit have to be the same thing, and they have to be a real number. So they both have to approach 2, and then that could be your limit. Okay? So we have a few examples here. And I know sometimes this is hard to read on here. Just go ahead and make this bigger. Okay, so for example 1, we want to just find all these limits, and then it's going to ask us if the limit exists. So for part A, it says that the limit as x approaches 2, and it does have a little minus sign here. So remember that minus sign tells us from the left. Alright, so we're looking at approaching 2. So I'm going to put a box around this 2, just so you know that's what we're trying to approach. And we're coming in from the left. So we start from the left, and we come in from the left side. We're looking here. Well, these y values keep getting bigger and bigger and bigger and bigger and bigger and bigger. Remember, we care about the y values. So because they keep getting bigger and bigger, this is going to be approaching positive infinity. Okay? So then, for part B, it says the limit as x approaches 2, and it has the plus, so that means from the right. So we're still looking at this 2, but we're coming in from the right side. So if I come in from the right side, well, those y values are still getting bigger and bigger and bigger. We care about the y values, so the y values are approaching positive infinity. Okay. Part C is a little different. It has nothing to do with limits. It's just asking f of 2. So it's asking if there is a point, so you're really looking for a point at 2, then it just wants to know what is the y value. Let's just write what is y value. Okay, this graph's a little hard to see this because at 2 we have an asymptote there. Okay, so because we have an asymptote there, there's no actual y value. So this would be considered undefined. Okay, because there's no actual point there with the thing. And the reason is because we have that vertical asymptote. Alright, part D goes back to what we were talking about in part A and part B. Part D says, does the limit exist or not? So let's go back to what our limit existence theorem says. It says the limit exists if and only if the left and the right are equal. Well, they were both infinity. But it has to be equal to b, and remember b has to be a real number. Well, infinity is not a real number. So because they both approach infinity, okay, and that's not a real number, then the limit doesn't exist. So we're going to write no, the limit as x approaches 2 of f of x does not exist, and that can be represented by d and e. Okay, you can use that on the AP exam. But it does ask us why. So because we're going to say the limit as x approaches 2 from the left, and the limit as x approaches 2 from the right are not real numbers. And remember, for the limit at 2 to exist, it would have had to have been real numbers. Okay, so we're going to take a look at example 2. Same kind of thing, we just have a different graph. It actually asks the exact same questions. So for part A, it says the limit as x approaches 2 from the left. So, looking at the left, let's go ahead and put a box around 2 just so we know where we're looking. So if we come in from the left side, we are approaching this hole here, okay? Well, remember, all we care about is the y value. Well, the y value here is actually 2. So 2 is going to be our answer there. So let me say that again. As you come in from the left side, the x value 2 that we're getting closer and closer to, remember it's a hole, but that's perfectly fine if it's a hole. We just care about the y value is getting closer and closer to, which is that 2. Okay, then it says the limit as x approaches 2 from the right. Okay, so if we come in from the right, well, we're approaching the same hole. So we're still approaching that same y value of 2. So I'm going to skip part C for a second and go on to part D. It says, does the limit as x approaches 2 exist or not? Well, look at your left and look at your right. Are they the same number? Yes, they're both 2. Is 2 a real number? Yes. So for part D, we can now say yes, the limit as x approaches 2 of f of x exists. And our reason, we can say because the limit as x approaches 2 from the left is equal to the limit as x approaches 2 from the right, and they're both equal to that real number, which gives us 2. Okay? Alright, so going back to part C, we said that when it says f of 2, we're really looking for where there's a point. So guys, if you look, there's actually at the x value of 2, we have a hole and we have a closed-in circle, okay? What this means is if you were graphing this, the graph would actually jump down, and this is the actual point there, the actual place where it's defined, okay? So when they ask you for f of 2, this is what you're looking at. So we need to know what the y value is at 2, where it's actually defined, and that would be -3. So this is your y value where defined. Okay? Alright, and then our last graph here. Focus. So if we're looking at example 3, different type of graph, same type of questions. So the first one says the limit as x approaches 2 from the left. So let me box off 2 so we know where we're looking. So when we come in from the left, well, this graph has a jump here, okay? So when we come in from the left, that y value that we're looking at there is 3. So 3. Okay, and then for part B, it says the limit as x approaches 2 from the right. So if we come in from the right, look in here, well, this approaches a different point at 2. This approaches a y value of -3, so this is going to be -3. So like we did last time, let's skip part C for a second. Let's go down to part D. And it says, does the limit as x approaches 2 exist or not? So remember the limit existence theorem. They have to have the exact same limit for the left and right, and it has to be a real number. Well, this one's 3 and this one's -3. Those are not the same. So we're going to say no, the limit as x approaches 2 of f of x does not exist. And our reason is because the limit as x approaches 2 from the left is not equal to the limit as x approaches 2 from the right. Alright, so for part C, to go back to that, we're trying to figure out f of 2, so where it's defined. So you're looking for the closed-in circle. Okay, so let me just draw an arrow here. So you're looking here. So the y value where it's closed in is going to be that 3.